Hey guys, it is me. Welcome to my lecture video for gas chromatography or experiment 6. If you're in group B, this is the first thing you're going to be watching. But if you're in group A, you won't be watching this until after you're done with experiment 5. So if you're in group B, I'm going to let you guys know now this lecture video is going to be, well, for all groups. This lecture video is going to be really short, just because obviously when you guys had read through the lab, you saw that it was pretty short as well. And that's just because experiment 5 and 6 usually go hand in hand. When we used to do in-person lab, we would get some data from experiment 5 and then utilize that further on with experiment 6. But because everything is online, we will just be having those labs separate. So if you're doing experiment 6 right now, just utilize the online information, the online data that we have given to you guys, and use that to answer your questions, all right? But if you're in group B, please watch the videos. Well, if you're in any group generally, just please watch the videos before you watch this, because otherwise you won't understand what I'm talking about, especially if you're in group B and you didn't go through the lab and experience the gas chromatography part. So yeah, but make sure you guys watch the videos so that way you guys know what I'm talking about, okay? So gas chromatography. Gas chromatography just separates the complex of mixtures of substances. It's just a way for us to separate polar and nonpolar items, compounds, not items. So whenever we're going through gas chromatography, compounds that pass through the column very quickly will have fewer intermolecular interactions. But whatever compounds that bind to the column, that will mean it has stronger intermolecular interactions. So that would mean, compounds that pass through the column quickly would be like more nonpolar molecules where they have fewer intermolecular interactions, other than polar molecules where they tend to interact more. So because we're using reverse phase chromatography, we are going to have a stationary and mobile phase. We're going to have a polar mobile phase and a stationary nonpolar phase. So in this case, so whenever you see the GC, it's like this box, right? And you inject your substance into small little hole. So there's a metal column where you're injecting it. That metal column with the nonpolar coating, that's going to be your stationary phase. And then whenever you're injecting something in, you're going to feel this, well, even when you turn on the GC and you're trying to adjust the pressure and having it ready to be injected, you're going to hear this hiss, and that's the atmospheric air. And that's the air that kind of brings in the sample whenever it's injected in the column. So that will be your mobile and stationary phase for this case. And then the last thing I want to talk about today is retention time. So retention time is the time it takes for the compound to exit the column after injection. So as you saw in the video, you're at the same time, you have one person injecting it and one person starting the lab quest for your graph. So it's very important whenever you inject it, because then you can, you have to do it at the same time, because that way you can be able to see the full graph. You can see you're going to have more than one curve, especially in the beginning when you have that mixture ready to go. You're going to see two curves, and that indicates two different things in the compound. And you'll see that more in experiment 5 when you make your own graph. You'll see 2 butanol and 2 pentanol. And then you're going to see further on, because you collect 3 samples in total. So the third sample, you're going to see that the first curve that represents 2 butanol is going to be a lot lower, or won't even be a curve at all. And the only curve you can indicate is 2 pentanol. And that means that we, for the most part, separated the mixtures really well, obviously, because that was our goal. But that's why retention time is really important, because that way we can get our data and we can be able to see exactly our substances. So factors that affect retention time. So compounds with lower boiling points will move faster in the column. That will affect it, obviously, because obviously it's going to boil a lot faster than non-volatile compounds. Instrumental settings can be a factor that affects retention time. So we really couldn't do this, but You could adjust the pressure or raise the column temperature if possible, and that can reduce time as well. And then the molecular weight of a compound or something in a compound. So obviously heavier molecules move slower in the column, but obviously that really provides a small effect. So yeah, so that's basically it. Again, I would honestly review experiments 5 as well when you're going through experiment 6. Definitely take into account what you had obtained and what you've learned from experiment 5, because that carries on again with experiment 6, even though we're using 2 completely different data sets, right? But I hope you guys are having a really, really, really great time, great day. I am very stressed out, so hopefully we can all get through this together. But just make sure you guys are going through the videos and going through the quizzes, and make sure you guys do your lab reports in time, your lab notebooks, and I will see you guys in person labs. All right, bye guys.